This is a recording to determine the average and the standard deviation of some data, and I'm going to do it several ways. One is with an online statistic calculator, then with a TI-84, and then, so to say, by hand. We're still using the calculator though, but I'm using the theory behind the standard deviation. Anyway, let's get started. These are some old student data that I still had, and I took off the obvious outlier here, and then we can see that these are the computed results for the acceleration due to gravity. And I'm going to start with a scientific calculator. Respectively, I'm going to try. When I googled online scientific calculator, I tried quite a few here, and none of them offers me a statistics function. So if you have a scientific calculator, try to figure that out. Respectively, go to an online statistics calculator, and I chose the second one, I think because the screen is bigger. So here we go. I don't need the variance, but I do need the mean, and I do need the standard deviation, just a tiny bit off the screen. There we go. Okay, now I'm going to put in the data, and I would write 979, 986, 979, but notice they all start with a 900, and I'm just going to be lazy, and I know that my average is going to be 900 something, and I'm going to skip the 900 itself and just type in 79, 86, 79, and so on. When you do a lot of data crunching, tricks like that come in handy. So I'm going to type these in here: 79, 86, 79, 87, 75, 86, 86, and 79, and I got 368 data, 368, yeah. And then I'm going to just hit compute. And there it is. The mean, the average is 82. Obviously that means 982 centimeters per second squared, and the standard deviation is simply the 4 here, which means 982 plus minus 4 centimeters per second squared. And that's with a statistics calculator that I found online. So that was pretty straightforward. Now let's do the graphing calculator, in case you are using a graphing calculator. So here's the TI-84, and I'm gonna find, to put in the data first, I need to open these curly brackets, and I'm gonna type in the data: 79, just like before, 86, 79, 87, 75, 86, 86, close that. Now, the other online calculator I found was, of course, straightforward because it's already programmed to do exactly that, and really quick. On any other calculator, including graphing calculator, it takes a few more steps or to achieve that. So I'm going to hit here, save it. Whoops, before I do that, store. Oh, what do I do now? Do that again. Store to L1. There we go, there it is. Hit the stat button, go over to calculate. This is what I need: one variable statistics. I need to tell it to use the L1 data list, by the way. L1 is down here after hitting the second button, and the store that I used a moment ago is right here. So here's the L1. Hit enter, and there it is. Again, 982 plus minus 4. Right there's the sigma, the standard deviation. Okay, if I do it by hand, which means I'm still going to use the calculator, of course I add these numbers here. And as far as determining the average, that is really the easiest way to do it anyway. Just add all the data. And then divide the result by the number of data, and there were 8 of them. And there it is again, 82, which is 982. Notice as I'm crunching all these data, it really comes in handy that I skip the 900 and just add that at the end. Okay, doing it by hand for the standard deviation takes quite a few more steps. So I'm just going to get my data points back that I can look at them. I don't actually need the 657 here, but I need these 79, 86, and so on. And I need that the average was indeed 82. So let's see, let's get that back. There we go, 82. And what I'm going to do now is I subtract 82 minus 79, 82 from 86, 82 from 79, and it doesn't really matter if I do that, in which way I do that, if I get a positive or negative number, because I'm going to square them anyway, and the square, of course, always is a positive number. So 82 minus 79 is 3, and I need to square that. 86 minus 82 is 4, and I need to square that. 79, 82, that's a difference of 3. 87, 82, that's a difference of 5. 75, 82, that's a difference of 7. 86, 82, difference of 4. That's how I should have explained it earlier. Just take the difference between the two. 4 again, and 3 squared. Hit enter. Divide by the number of data, which is 8. And finally take the square root of that, and that's the standard procedure to figure out the standard deviation. And I come again up with 4. So 982 plus minus 4. These are the 3 ways that I wanted to show it: graphing calculator, by hand, so to say, as well as a statistics calculator. And the only thing I couldn't find was an online scientific calculator that would actually simulate that. But here it is, 3 different ways of figuring out the standard deviation and the average.